All right, chapter 4, algebra and integers. First things first, before I even mention the word absolute value, I kind of want to go back to the number line. Example 2 plus 3, and then example 2 minus 5. 0, 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. To the right is positive. To the left is negative. Negative 5 and 5. So the thing goes by ones. And we have an example, 2 plus 3. Here's 2. You're adding, so you're going positive to the right. Yeah. Okay. So that answer is 5. Super easy, right? But now when you do 2 minus 5, you are moving to the left 5 times. And I encourage you to think about integers and negative numbers in this fashion. You are just moving left of along the number line, okay? Hopefully it's a refresher. 3, 4, 5. But 2 minus 5 is going to be this spot right here, which is negative 3. Okay, that's your crash course in integers right there.
So it always makes a number negative? That's
Other way. You're talking about absolute value?
absolute value makes a number
Not negative. Positive. So absolute value is a function with the 2 lines. And anytime you see that, you make the number positive. So, symbol for absolute value. Bless you.
Thank you. I am not sick. I'm not sick. You're going to make me sick now.
I'm going to make another example here. So if I do negative. Okay, so 2 over 5 with a negative in front of it is still inside the brackets, the straight brackets. That means I make it positive and I write 2/5. However, notice that the negative's on the outside. So the 5 over 6 is already positive. What does the absolute value do? Nothing. You just leave it positive. Okay, so this is going to become 5 over 6, and then you have the negative in front. So believe it or not, this answer doesn't change.
will just stay positive.
It's negative 5 over 6. Okay? Look at the negative 3. It's inside the absolute value, correct? So what's the answer? 3. What's this answer? negative absolute value of negative 12. Now they start giving you like double negatives and stuff. What would be the final answer? Negative 12. Yeah, I know. This part becomes positive 12, but you just have to remember you have a negative hanging out there, so
Negative hanging out there.
yeah, it's outside of the absolute value.
So whenever it's outside, it's negative?
Whenever it's outside, you don't make it positive. I know I worded it differently, but okay, look, here's the example we just did. 2 minus 5 is negative 3. But now we have an extra step, right? What happens to the absolute value? Positive. So let's write this as 2 plus 5. And now this answer is 7. Okay, ignore it. Do the absolute value first. So that becomes positive. And now this has 2 minus 5, so it's the same as the first one. Right? So I'll make one more note about this. Star. Evaluate the absolute value first. So it's like order of operations. Think about part A for about 30 seconds. Any volunteers for part A? All right. You missed an important slide. I think you're one off. You're one off on it. 15 is the answer, yeah. Okay? Make the 3 positive and write it as 18 minus, and then 15. Now, in part B, treat the absolute value as parentheses because like you're doing that first. So in your head, do 8 divided by 2. You have to think of the absolute value as a separate. Okay. Now, look at the absolute value. Then you have the other negative here. So in part B, it's going to be absolute value negative 4 minus absolute value of negative 9 plus absolute value of negative 4? Oh, it's hard to tell. So it's kind of like this. Yes, Michelle.
Why is it a negative 4 if it's in the bracket?
I didn't evaluate the brackets yet. All I did was the division.
Okay,
So yeah, if you're doing that in your head, that's perfect. But I'm writing out every single step. All right, so yeah, you're at the point where you're writing it as 4 minus 9 plus 4, right?
right.
And I got negative 9 as an answer. No, sorry.
It's negative
1. Negative 1. Thank you. Okay, part C is going to be, remember, absolute value is kind of like parentheses. So I'm going to do 12 minus, now this 3 becomes positive, plus, absolute value of a quantity, right? So now do 13 minus 20 first. Which is negative 7. Now evaluate that absolute value. Next line will be negative 12 minus 3 is 9. Plus 7. So negative 9 plus 7 would be negative 2. It's beautiful. Yeah, it's beautiful. All this crazy stuff boils down to a nice simple answer.
So is it the brackets that make the number positive?
Correct. It is the brackets that make the number positive. Yes. This is absolutely, yeah. Yeah, I mean, actually, we don't. Yeah, so like, now that you mention it, that's just like, treat it like parentheses. This is the actual notation for the function, right? So it's got to be the two straight lines. All right, let's think about this for a minute. It says the table shows the percent change in goods for the past 2 years. Milk, eggs, gasoline, bread. And it's asking you which has the smallest change or the smallest difference. So I got to think about this for minus a negative. So that would be 13 minus.
Literally what I said.
Okay, I'm trying to think of a way to explain it in terms of absolute value, but if you take like 5.1 minus the absolute value, no, it's really added. Actually, I think you don't need absolute value. So if I do 5.1 and subtract them, like minus negative 0.6, if you think about it on the number line, like here's 5.1, and this is negative 0.6. So you're thinking of like what's the whole distance between them? So I'm really doing 5.1 plus this distance right here, which is 0.6. So I'm going to do 5.1 plus 0.6. So that change is 5.7. That's the total change. Now let's do the next one. They're both negative. So I have negative 49.7 and then negative 13.8. I'm interested in this distance. So what would I do to find the change between them? Somebody said subtract, right? So like 49.7 minus 13.8, and you would find the difference of it. Oh, this thing. 49.7. 35.9. Somebody said it, right? Okay, so this one is 35.9, and so on. So now I have 0 here, 2.5, 8.3. What is this change? So 8.3 minus 2.5. 876. 5.8. Thank you. And then the last one. 0, negative 4.6, negative 1.6. That difference would be 4.6 minus 1.6. So I think that's 3, right? Whoever said bread got it right. kind of a problem. If you props for you. I like your style. But that would be the word problem, one of the harder ones you'd get. That brings me to the very next thing. 2 negatives will equal a...
Positive.
My people. So we throw all kinds of negatives at you. It's great. 8 minus 3 is 5. But now, two negatives equal a positive. So like a lot of things that people always do, they say, okay, two negatives is a positive, so they just kind of combine them. So we turn that into plus. These two I wrote on purpose because they're the same thing. Now if you put parentheses in there, imagine that this negative gets multiplied together with the other negative, so a negative times a negative is a positive. This is the same thing. And then this one is negative 8 plus 3. So you can get a lot of different answers depending on how the problem is set up. All right, I'll do the first one down here. Negative 2 plus bracket 3 minus parentheses quantity 18 minus 25. There's two sets of parentheses going on. I'll write everything out. So my first step would be to do these right here. (18 minus 25). Negative 7, I think. Next line. Negative 2 plus bracket. Now that becomes a positive. A negative times a negative is a positive. So this is going to be 3 plus 7. And now I'm going to do negative 2 plus 3 plus 7 now is 10. And then finally, negative 2 plus 10, which is 8. Part B. What would you like to do first? Four minus one comes first. Okay, what would you like to do next? What would you like to do next?
No, 2 minus 3.
2 minus 3. Not quite. Remember order of operations. Multiplication in there. Right here. 3 times 3 is what? 9. That was the hard part, I think. All right, what would you like to do next? Treat brackets like parentheses. So we have to go here first. 2 minus 9. You got a calculator? You have a calculator? There you go. Notice how I'm keeping the bracket there, right? I'm being very specific. Don't write 16 minus 7. It's 16 minus negative 7. So 16 minus negative 7, 23.
So you have to do the leftover parentheses first, so like 3.
Where? In here?
Yeah, for the second one, so you like, you leave the 4 minus 1, you leave it in the parentheses because it's in the bracket,
Correct.
and then after that you do 3 times 3.
Yes.
So you wouldn't do 2 minus 3 and then,
No, you would not, because think back to order of operations. You have to do multiplication before addition. So, yeah, so think of it as like a little times in there. You got to do that first, right? Multiplication before addition. Hey, numbers turning into words. Write a numerical expression for the phrase. 6 times the sum of negative 8 and positive 20. Key words, right? Times is going to mean multiply. But it gets tricky because the word sum, you have to think of a quantity. And that will trigger, in my mind, parentheses. So 6 times the sum of negative 8 and positive 20. Twelve divided by so when I write something like 8 divided by 3, the 8's on top. 8 divided by 3. 4 divided by 2. So I think that the 12 is going to be on top. 12 divided by the difference, but difference is going to be addition. So the difference of negative 3 and positive 18. So I think it would look something like that.
we're going to be past 18, so this is different.
Difference, it means subtraction, right? So really, I probably should have written it like this. Because that's positive, I suppose. All right. Eight subtract from 20.
Oh, 12.
The answer is 12, exactly. So notice that when I really think that you might see a question like this. Notice that when it's from, like that's where the start of it is. So it's really 20 minus 8. 8 subtracted from 20, 20 minus 8. And then why did I do that? Because I'm setting you up for this one where it says now it's 1/4 of a number. So now this one, we're going to call x. 1/4 of a number subtracted from 8. So which is going to come first? The 8. So we're going to write 8 subtracted, okay, so from 8, 1/4 of a number. And believe it or not, that's the answer that they want in the computer. So the thing that I didn't quite explain was when you see the term a number, you are going to introduce a variable. A number means use a variable. So it's not a number. Every single math textbook on the planet uses x as the first variable. You know, you could really name it x, y, or z, or whatever, but 1/4 of a number uses x. I'm going to stop right there for the moment.